Okay, great to be here. My name is Lintunen, work at the University of Helsinki. I'm Academy Fellow and University Researcher. And I'm bringing you greetings from the ACCC Flagship. And I'm talking about the role of forests in climate change mitigation, so a bit different perspective. Well, forests are important for a global carbon budget, which I think this audience knows. So you can see here, I will change the settings here so that I can actually see the slides myself as well. So we can see here the emission and sinks of carbon dioxide in billions tons per year. So from fossil fuels and industry, you can see there on the left-hand side. Then emissions from land use chains. Then we have large terrestrial carbon sinks, and we have ocean sinks. So forests matter in this big picture. Now the slide is not changing anymore. Can I use that as well? Can I try that? No, nothing happens. Okay, here we go. Perfect, thank you. So then the role of natural carbon sinks in Finnish net zero path. So we want to be carbon neutral in Finland by 2035, and there is a plan for that. You can see here above the zero line the carbon emissions with this kind of gray color, and then below the line you can see with light brown color the net sinks of LULUCF sector, which means the land use chains and forestry. Well, we have a good trend there regarding the emissions. They have been decreasing in the last 2 decades, but unfortunately so have been the sinks decreasing. So our land use sector was a strong sink in previous times, but now today it's actually a net source of CO2. So our land use sector is emitting more CO2 to the atmosphere than capturing it. The forests are still small sinks, but especially the agricultural lands on organic soils are large emitter of CO2. You can see there also the planned net zero path, and you can also see there with this kind of columns what is the role of emissions and sinks in that target path. So the Atmosphere and Climate Competence Center Flagship aims at carbon neutral Finland and beyond. Wow, that's a big goal. Our partners are University of Helsinki, Finnish Meteorological Institute, Tampere University, and University of Eastern Finland. And how we implement our work is through 3 research programs, you can see there in the middle, and 16 impact tasks, out of which 3 we have already accomplished. And we have wide collaboration and stakeholder network, as I can see that Finseras has as well. Today we focus on this research program 1, potential of land-based climate change mitigation, that I'm leading together with Jari Liski from FMI. So some kind of snapshots from that research program. So what is the impact of forest use on carbon sink? If we compare first young and old forest. And this kind of exercise is process-based, done with process-based modeling tool called PREPAS, and we are looking at the carbon dynamics above ground. So we can see here, let's start by defining what is carbon sink. So positive change in carbon storage. So we can see here how the carbon storage dynamics change when we have, let's say, a normal rotation period of 75 years in southern Finland. There are some thinnings done on the way, and then there is a clear cut, so the carbon storage is kind of emptied, and then a new forest is established. Then if we alternatively do not do the thinnings and do not do the clear cut, but we just leave the forest growing and become older, we can see that the forest growth rate is decreasing, but the carbon storage is large. So clear cut makes forest young, which increases forest growth rate, but decreases forest carbon storage when we look over the whole period. Then a study based on field measurements on nutrient-rich drained peatland forest. So how it's measured is that the gas exchange is measured above the forest area. And before any harvests, the site was kind of quite climate neutral in terms of carbon. So a small source or small sink depending on the year. Then 2 optional harvests were done. With black color you can see the clear cut, and then with gray color you can see the partial cut. So just some of the trees were removed, which aims for continuous cover forestry. So partial harvest caused less greenhouse gas emissions than clear cut. Same was true for the nutrient leaching. And carbon dioxide here dominated on the climate impacts of these management options. Methane played a minor role, and N2O was significant, but not at all as significant as CO2. So, kind of to conclude, based on this study and many more, on nutrient-rich peatlands, clear cuts are not climate smart, also because of the water table level that it affects. Then study based on process-based modeling where compared different harvest levels in Finland. So there are 4 different kind of management scenarios that you can see there. Blue color is the base scenario. So this is following the Tapio forest management recommendations that are quite generally followed in Finland. Then there is adaptation scenario, which means that forest health is prioritized. Mitigation scenario that carbon sink is prioritized, and protection scenario where biodiversity is prioritized. And then there are 3 fixed harvest levels: business as usual, low harvest, which is 40% lower levels, and high harvest, which is 20% higher levels. And we can see that what really drives the carbon storage is the harvest level. So the changes in management, which means rotation period and fertilization and species mixtures and things like this, in the big picture, they don't matter when we compare to the harvest level. But then if the harvest levels were allowed to change, as you can see with these blue columns, then the harvest levels were lower in these mitigation and protection scenarios than they were in the base and adaptation scenarios. Now here is something funny with the order. So then a study based on optimization modeling combined with forest growth models and reinforcement learning. So this is kind of methods known from economics. And this was, at least for me, a bit surprising result that pure climate mitigation effect, so carbon sink, is maximized with clear cuts when the rotation period is very long, like 250 years. If you do no harvest, you can see with this kind of triangles, what is then the green is the total. Green color is the total carbon at the site. So we can see that the average annual carbon storage is smaller in case of no harvest when we compare it to a clear cut, when the rotation period is long enough. Also, partial harvest or continuous cover forestry was not optimal if only carbon sink matters. It was also not optimal in case the carbon cost is high. And this is because, in this case, it makes sense to grow the forest very dense. And when the forest is very dense, the regeneration does not succeed anymore. Well, then the forest has also other kinds of climate impacts than the carbon, which we have already discussed. They also affect albedo. And albedo means the fraction of sunlight that is reflected back to the space from the surface. And forest is a dark surface, so its albedo is smaller than, for example, if we compare to a grassland or a clear-cut site. And this is a warming impact on climate. Carbon sink is a cooling impact, albedo impact is a warming impact. Then the forest also emits volatile organic compounds, and they are something you can smell in the forest. And these volatile organic compounds, when they get oxidized in the atmosphere, they take part in aerosol formation, so small particles in the atmosphere. And when they grow in size, they can act as cloud condensation nuclei, so like small seeds for cloud droplets. And both clouds and these aerosols, they also reflect sunlight back to the space, and this way cools the climate. and the biodiversity. Also important, let's not forget. So then one study based on modeling where all these different climate impacts are considered. So let's first look without the substitution effect, which means the effect of wood, like we consider the carbon stored in wood products and also the emissions that are avoided from fossil fuels when we replace by wood products and energy. So on y-axis we have change of radiative forcing, so meaning that when the numbers are positive, it's a warming effect, and negative, it's a cooling effect. And we compare their different harvest levels in Finland. The baseline is that 65% of annual increment is cut, and then, or you have higher levels and lower levels. And we can see that when we consider all these effects, so albedo, carbon, aerosols, when we increase the harvest levels, we have a warming impact on climate. And when we decrease harvest levels, we have a cooling impact on climate. When we consider the substitution effect on the right-hand side, then the differences are not anymore that big, but the story is still the same. And here still to summarize the same thing, we can see when we go from right to left, we are increasing the harvest levels. We kind of see how big role each compartment are playing there. So we see that CO2, carbon dioxide, the sink, still has the highest, like the biggest impact. The substitution effect comes second, at least in this study, and then the albedo and aerosol effects are kind of less impactful. So to conclude, how to mitigate climate change with forests? Decreased harvest levels, longer rotation periods, continuous cover forestry favored in nutrient-rich peatland forests, reforestation of abundant agricultural lands and avoidance of deforestation, and wood-based products with longer lifetime and or with higher substitution effect. Thank you, and the references are here.